values again. Let's start with the return values or events in general. The EVM has a logging functionality. This is actually what is behind those events. It's logs, they are stored on a side chain, and you would define an event with a keyword event, and then you have the event name in a kept words style. One thing that I haven't talked about is the indexed keyword. If you define any of your event parameters, and this can be up to 3 parameters as indexed, then they are being hashed and you can search for them later on in the side chain if you want to go back in history and search for them. Now, there are 3 main uses or use cases where events are used. The one is return values. We have seen that, where you can return specific values when a function is triggered or when a transaction is actually mined, then these events are triggered. They are also for a trigger functionality, and I'm going to show you in a second an example of that, and they are a cheap data storage. Now, events can emit data which is stored on a side chain, and it's much cheaper than storing it in, for example, strings on your storage variables. More on that in a second later. Why use events as return values? The problem is you've seen that on a live chain you cannot return values. If you run a transaction, the transaction will actually return a transaction hash. And the problem is this transaction can have a couple of different states before it's actually mined. It can be pending, it can have an error, it can succeed, it can be again rolled back because another chain was longer. The point is, events are here to actually inform external users that something happened on the blockchain. And this can be return values. And the other version is that it can be a trigger. Imagine something like this token contract we had, or a multi-signature wallet smart contract where you have different people put in money. Let's say this is Alice and this is Bob, and both are putting in free ether, but you need at least 2 people to approve a withdrawal. Now, Alice is trying to withdraw free ether to another person called Paul, but she needs another one, namely Bob, to approve this request. Now, if there is a function inside the smart contract that said like withdraw free ether to Paul, and then it would emit an event that Alice is trying to withdraw, but she needs another approval, then Bob or Bob's MetaMask or Bob's external application can listen to those events and then can inform Bob, hey, Bob, Alice want to withdraw free ether, are you okay with that? And then Bob can call another function in the smart contract to actually allow or approve this request. This would be a standard events trigger. Now, events as a data storage is a totally different category. The problem is storing data on chain is extremely expensive, and there are a couple of solutions to that. One of them is store data completely off chain and maybe just a hash on the chain, so to make sure that the data that is stored off chain is still valid, or store data on another blockchain such as IPFS, or if you just have strings, then you can store data in the event logs if they are not necessary within Solidity code. I've researched a little bit how much it would actually cost to store 1 megabyte on the Ethereum blockchain. And I came to this article here from Medium, from CoinMonks. I will post a link in the description of this lecture so you can check it out yourself. Just a quick idea to give you, we are talking about storage and we are talking about the opcode, the EVM instruction S-store, and this would cost roughly 655 million gas per megabyte or 640,000 gas per kilobyte. And if we are putting this into something more understandable, then we are talking about writing. We have between 3 and 32 ether per megabyte that we need in order to write 1 megabyte to the Ethereum blockchain. The gas usage depends on how fast you want to have this transaction to be mined. And in terms of US dollars, that would be between $4,000 and $44,000 per megabyte to write something. It's definitely worth it to check out different methods of storing 1 megabyte of data because it can be much cheaper. There is a really good example that I found, which I found is a fun example to just check out the source code. It's a game that is called Adventurium. It stores, the game is about that you have a story and you can choose between options. I also could put the link in the description of the video. And you are in the woods, and there are 3 roads. One is leading to a house, one is leading deeper in the woods, and one is leading to, a school. Is option A, B, and C. Which one are you going to take? You're going to the house, and then you have another 3 options. You're going inside, you're going around the house or in the basement, and so on and so forth. So there's a path, and this path can be extended by users once they reach a leaf. So once there's no more options, once they reach the end, the users actually themselves can extend this path. And there's strings attached to it. So the path 1 would be you go to the house. The path 2 would be you go deeper into the woods. And the string itself for this path is stored as an event. And I found it kind of a cool, fun way to do something like this. It's kind of interesting how they came up with the idea. So how does that actually look like, and what is the idea behind events? Now, when you write smart contracts, obviously at some point you want to interact with smart contracts from outside of Solidity. You want to have your smart contracts being the logic code that is stored on chain, but you have to somehow start transactions to interact with that and then get something back. And that would be in those decentralized applications. They live outside of the blockchain, and they are just like a view layer where you have the database on the blockchain and your applications outside of the blockchain. Now, an event cannot be used inside Solidity, meaning you can emit events, but you cannot do anything with the event values. So if you emit an event and it has a string attached, you can never access that string inside Solidity, but you can access it outside. So this is where applications can actually subscribe and listen to these events, and the Ethereum nodes will trigger these events through the RPC interface to the application that is listening to it. And we are doing this in this lecture, in this course, a little bit later. Events are inheritable members, so if you are going to have events in one of your smart contracts which you extend, then these will be emitted as well. And the indexed parameter is here that you can later on search for these events, and you can actually check it out in the Adventurium game if you want to give it a try right away. Now the key takeaways: if you need return variables in writing functions, then use events. Using events is always a good idea to get an idea what's going on inside the smart contract. If you need a data storage or a trigger, use events. They're really cool, so you don't need to poll something. You can just inform someone outside. You cannot retrieve events from within the smart contract, so remember that. If you really need to store strings or any expensive kind of information on the smart contract, then you have to. You cannot use events for that. But if you